This video is going to review the SI system, temperature, and density. The International System of Units, or the SI system, consists of a set of base units and a handful of prefixes that all represent a power of 10. First, you have to know the base units for various types of measurements. For length, the base unit is the meter. For mass, the gram. For time, the base unit is the second. When we're discussing smaller times, scientists do use the prefixes on the base unit of second. For example, a computer process might take 3 milliseconds to complete. When discussing larger increments, though, scientists use the typical measurements like minutes and hours. The base unit for volume is either liters or meters cubed. Liters is most commonly used when measuring liquids and gases. Meters cubed is more often seen when you're discussing the volume of a solid. SI prefixes, as I said before, represent a power of 10, which is the same thing as moving the decimal one position. You need to know all the common prefixes from mega down to pico. So going down the line, these letters stand for mega, kilo, hecta, deca. U represents the base unit, any of the base units we saw on the previous screen. Next is deci, centi, milli, micro, nano, and pico. Make sure and notice the empty spaces outside of the common kilo to milli set. These empty spaces either have no assigned prefix or their prefix is rarely to never used. You have to remember to include these empty spaces, though, because you have to remember to move your decimal through them. To move from milli to nano, for example, is not just 2 shifts if you're thinking after milli comes micro and then nano. Milli to nano is actually 6 moves of the decimal if you're remembering to include those empty spaces. Practice by completing these metric conversions. Convert 0.15 nanometers to picometers. We're starting on the prefix nano, and we're moving to pico. That's moving the decimal to the right 3 times. So we get that 0.15 nanometers equals 150 picometers. 37,000 centimeters. Starting at centi and moving to meters, which is a base unit, means moving the decimal 2 times to the left. So 37,000 centimeters is 370 meters. To convert this number from meters, which is again a base unit, to nanometers involves moving the decimal 9 times to the right. This answer then is 21 nanometers. Millimeters to micrometers moves the decimal 3 times to the right. This answer is 4.6 micrometer. Lastly, 305 meters equals 0.305 kilometers. Moving on to temperature. First, remember that temperature is a measure of the kinetic energy of the particles that make up an object. Kinetic energy describes how fast the particles are moving around inside the object. The SI scale for temperature is the Kelvin scale. A Kelvin temperature is like a direct measure of the amount of motion of the particles of the object. 0 on the Kelvin scale is the lowest possible temperature because it represents the point where there is 0 molecular motion. You can't have any less motion than no motion, so there's no temperature lower than 0 Kelvin. This is called absolute zero. That's why the Kelvin scale is known as the absolute scale. Here's a nitpicky but necessary detail you need to remember. On the Fahrenheit and Celsius scales, the unit is called a degree. So we talk about 97 degrees Fahrenheit, 34 degrees Fahrenheit. On the Kelvin scale, there is no degree. The unit is a Kelvin. So don't use the degree symbol in the Kelvin scale and don't say degrees Kelvin. 298 K would be read as 298 Kelvin, not 298 degrees Kelvin. You must know in your head how to convert between Kelvin and Celsius temperatures. Kelvin equals Celsius plus 273. So given a Celsius temperature, add 273 to get Kelvin. Given a Kelvin temperature, subtract 273 to get Celsius. Finally, let's discuss density. Density is a measure of how tightly packed the particles of an object are. It's the ratio of mass to volume, or mathematically, D equals m over v. To figure out the density of a regularly shaped object, like this rectangle, you would need to determine its mass by measuring it with a balance. We'll say that the mass of this rectangle is 540 grams. Then you're going to need the volume. For a regularly shaped object, we would do that by using a ruler and measuring its length, its width, and its height. Then you could calculate density, because you now have the mass, and you can calculate the volume. For this example, then, we'd have 540 on top, and 10 times 4 times 5, which is 200, on bottom. Solving, we would get that the density of this object is 2.7 grams per centimeter cubed. What do you do if your object is not regularly shaped, like a little toy dinosaur? You can still measure its mass with a balance, but what about the volume? You can't use a ruler and measure every tiny angle and section, so how do you measure its volume? You would use the process of water displacement. Put water in a graduated cylinder and record the volume. Drop your little toy dino in and measure the volume again. The difference of the two measurements is the volume of your little toy dino, 0.80 milliliters here. Once you have the mass and the volume, you could do the same calculation to determine its density.